Okay, it's getting to be about bedtime, but got to try this one more time. I have pulled off the IRF Z44s that are probably smoked. I had some IRF 640s, which I think are pretty similar in capacity. God, my family's all being loud. I have a thermometer hooked up to it now, but actually, I'm driving this off the oscilloscope that has a built-in frequency generator. And of course, it's stuck at 50% duty cycle. But instead of moving the buttons on my deal, which these did fry, by the way, there's a nice one of these ones has a nice bump on the screen or a nice blister on the little microprocessor right there. So that's toast. That's a surface mount. So I don't know how easy that will be to change, but I'm just driving it off the frequency generator. And I'm able to got this pushed up to the 100K, but I have this knob turned way down. So I'm probably running around 10K or something. I'm kind of able to adjust the frequency on the fly and kind of get to the optimum frequency to switch this transformer. And as this thing was starting to lose voltage and cut out on under voltage, I was able to fine tune that thing and actually get a pretty sweet spot, I believe. Now, the funny thing is when I power this up, again, the pulse width is fixed. So if I don't actually start driving the motor, it'll actually overdrive the voltage, and this thing will trip on over voltage because it'll start feeding 400 plus volts DC to it. So it's on 300 and something. Oops, powered right up because I left the run switch on. So look how fast that actually started. I have the efficiency probably golden screwdrivered right now. That's an old term we used to use back in the CB radio days of going in and like not using oscilloscopes and knowing what you're doing, but you would kind of like turn the tuning coils by hand and just have somebody else listen and dial in your CB radios. So that kind of a phrase is stuck. Golden screwdriver is kind of like what I'm doing because it's like I'm not running math and stuff to know exactly what frequency resonance this transformer likes. I'm just fiddling with it till I find it. So it's totally dead. Pretty much 6 volts. It's pretty much discharged now, dropping to zero. But it seems like it's only taken like just wow. That's starting up within a second. I hit the sweet spot. That's the input, and then the other one's actually watching 12 volt being driven, which seems to be driven hard. I finally realized I had 1K resistors going to the gate of those. That's a no-no. So I put 220 on there, and then 220 pull-up over here, and using two separate transistors, one on each MOSFET. Also, earlier when I was testing that with you guys, I forgot to connect this cable to the second gate. I was only running it off one MOSFET when you guys were watching earlier. And somehow when it did something, it backfed and fried my microprocessor, which sucks. Might have to use an opto isolator next time. Got the temperature going up to 133 degrees. It's measuring the temperature of this aluminum. But now I'm going to speed up this sucker. Now this potentiometer comes from a video game trigger. It sucks. I've noticed a lot of those things suck. So it's hard to get this thing to move. So it's 3 hertz. Try to bump it up. I've been able to get this ring to run up to about 20 hertz. Oops, there we go. 20 hertz. And of course it's unloaded. It seems like that's pretty happy. Temperature is 150, plus it's shooting up. Of course, yeah, as soon as I put a load on it, it will pull down the thing. So 20 hertz. Let's see, I'm trying to remember how to see. Oh, here it is. Oh, wait. So it's sending out 84 volts, 0.55 amps, 20 hertz. So obviously it's taking very little to drive the motor with no load on it. My transformer still little DC switching devices keeping it right around 200 volts. Like I said, if I switch this frequency thing, I can kind of fine tune the efficiency. Oops, he didn't like that. Go up a little faster. Starts dropping down too. So I found, kind of fiddling with that thing, I kind of found the right frequency for that transformer. So 20 hertz, of course, unloaded. Of course, I mean, what do you expect to run? I mean, this is literally running a 3-phase motor off a 12 volt, basically a battery, basically, through a little dinky transformer that was meant to step down the voltage for a printer. I'm stepping the voltage up. And 200 volts is just about the limit of when this thing will trip. So I probably can't turn this thing up any faster. 20 hertz. Oh yeah, see, it's gonna trip. Drop it down. There's 3. Potentiometer's real touchy. 16. Seeing its input staying over 200. 68 volts, 0.56 amps. I don't know. It's kind of funny to do. Now, if I build a real robust version of this, there's a reason I'm messing around with this. I need a bigger transformer, of course, a heavier duty circuit, handful of heavy duty MOSFETs. I want to step up. Probably not 12 volts. I'll probably use 24 volts for the power supply, for the batteries. But I was thinking of how cool it'd be to make. I'll probably never do it, but it'd be funny to put a 3-phase motor in Macy's. Ashland's too overgrown for the Jeep she used to have. Macy has her Mustang. I wanted to drop that Mustang body onto an actual steel frame with rubber wheels. It'd be funny to put a 1 or 2 horsepower 3-phase motor in that thing. I'd like to find a little more compact one than that. And drive it off a VFD with 24 volts or something battery with the batteries, lithium iron phosphate or something, which would shoot, then have my circuit shoot it up to the 200 plus volts DC that this thing will run it. This thing is capable of running about 1 horsepower, I think. And then they have the bigger VFDs. It's just doodling. I don't know if I'll ever do it, but this is kind of the test circuit just to show you that some of these VFDs, man, they're real versatile. There's no AC input. Whoops, and I just loosened my connection there. So, seem to be pretty stable at 186 degrees, which probably is hot to the finger, I'm sure. You can hold it for about a second before it burns the shite out of you. But earlier, that thing was scorching. I mean, it was getting those other MOSFETs so hot that it was unsoldering the wires. That happened several times before those MOSFETs cooked. But they're probably good in toast now. I mean, they don't look blown up, but they didn't seem to be switching anymore. Can't get the camera to focus. So, yeah, I got some going back to the drawing board. I got to change the microchips on those 2 boards if I want to use them again for projects. Might have to. I don't know how fast you could switch an opto isolator. Might just have to maybe design something with some Zener diodes or something just to keep any back voltage from going into there. The resistor should limit the current. Put a couple Zener diodes in there to keep to clip any high voltage or something from going back if you touch the wrong thing, or it back feeds through a blown transistor or something, because I don't know how. But there was a chance that this metal part, which is hot, to the power it is, might have touched right here and put 12 volts back into there. And I think that's actually what happened. This was sitting right here, and I bet you if we look back in the video, this is 12 volts. It touched here and then went back into that circuit. I'm pretty sure now that's what happened. I'm talking to you guys about it. It's still running. It's pretty much just leveled off on the temperature for the most part. You like that speed? Too fast. This potentiometer is so touchy. 21 hertz. This is a piece of crap, and of course I can go all the way down to 3, I think, which is what the programming must be in the VFD for the minimum frequency when it's in run. Look at that motor just barely turning. So it's 3 turns per second, so it'll be 1, 2, 3, 1, 2, 3. And depending on how many poles that motor is, it might not match that frequency. Actually, 3 hertz is what's being fed, so it isn't going to be 3 turns per second. 3 hertz feeding it. 60 hertz would do 1725 RPM, so 1700 at 60 hertz. So whatever 3 hertz is, that's the RPMs of the motor. I don't know. So that's pretty cool. 192 degrees. But, yeah, and then of course you turn the motor off, the voltage going way the hell up. So I gotta kill that circuit. 440 volts DC when I just pulled that. Oh, that's what I was gonna do earlier. I don't know. I might be a little psycho to do it. I was thinking of charging these capacitors up as far as this thing would do, and maybe run away from it. Because capacitors will explode eventually when you go well enough over the working voltage. So these are 160, 320 volts in series, and that's you're supposed to not even run up to what the max is. So I'm running at the max. But if I let that voltage charge over that for very long, it could blow those up in my face. So I don't know. Yeah, this is a mess. Time to shut down for the night. Power off. That thing's cooling off. Still 173 degrees. Ooh. It's weird that it jumped. Loose connection. But yeah, crazy. So I don't know. I'll probably not do anything more with that now. I just kind of saw that I could make it work. That's just amazing to run that motor with that little tiny transformer. But again, the motor's unloaded. As soon as I touch the shaft, and this thing tries to put more voltage for more, to maintain the speed, it just craps right out. So anyway, with that, I'll be out of here. It's time for bed.